Welcome back. We are still on the topic graph of quadratic functions. In the previous video, we solved a likely examination question. In this video, we are going to solve another likely examination question. The question for this video is: a stone is projected into the air. Its height h in meters above the ground after time t in seconds is given by h is equal to 26t minus 5t squared. A. Complete the table below for the relation h is equal to 26t minus 5t squared. B. Using a scale of 2 centimeters to 1 second on the t-axis and 2 centimeters to 5 meters on the h-axis, draw the graph of h is equal to 26t minus 5t squared. C. From your graph, estimate I, the greatest height the stone reached, II, the time it took to reach the greatest height, and III, the time it took to hit the ground. We are going to solve the first part of this question in this video, then we will solve the remaining part in the next video. So let's begin with the first part. The first part says that a stone is projected into the air, that is, a stone is thrown into the air, and its height h in meters above the ground and time t in seconds is given by h is equal to 26t minus 5t squared. We are supposed to complete this table given to us by using the relation h is equal to 26t minus 5t squared. To help us understand this question very clearly, let's consider this simple illustration. So let's say that we have the ground here and we have a stone on the ground. We are going to represent the stone with this red ball. The question says that this stone is projected into the air. That is, the stone is thrown into the air. We know that because of gravity, if we throw this stone into the air, it will rise up to a certain height, then it will drop back to the ground. So when we project this stone into the air, or when we throw it into the air, the stone will rise up to a certain height, then it will drop back into the ground. If we trace the path that this stone took, it will look something like this. So the stone was on the ground here, then it rose through the air up to a certain height, then it dropped back into the ground. In the question, we are being told that the height h in meters above the ground, that is the height reached by the stone above the ground, and the time taken by the stone to reach that height are connected by the function h is equal to 26t minus 5t squared. So as the stone rises from the ground through the air to reach this greater distance and drop back to the ground, the height that the stone reached at any point and the time taken by the stone to reach that height are connected by the function h is equal to 26t minus 5t squared. As we can clearly see, this function is a quadratic function because the highest power of the variable in this function is 2. The question says that we should use the relation given to us in the question, which is h is equal to 26t minus 5t squared, to complete this table. In this table, we have been given a set of t values, and we are going to use these t values to find the h values. So we are going to find h when t is 0, we will find h when t is 1, we will find h when t is 2, 3, 4, 5, and 6. That is, we are going to find the height reached by the stone, which is represented with h, when the time t is 0. We will find the height when the time t is 1. We will find the height when the time t is 2. We will find the height when the time t is 3. We will find the height when the time t is 4. We will find the height when the time t is 5. And we will find the height when the time t is 6. Remember that the time t is in seconds and the height is in meters. So let's do that. We know how to complete a table using a relation. So we will substitute each one of these t values into the relation to get its corresponding h value. The function is h is equal to 26t minus 5t squared. From the table, the first t value is 0. So we are going to find h when t is equal to 0. When t is equal to 0, h will be equal to, we have 26t, so we have 26 times 0 minus 5t squared, so we will have minus 5 times 0 squared. So h will be equal to 26 times 0 minus 5 times 0 squared. 26 times 0 is 0, 5 times 0 squared is 0, and 0 minus 0 is 0. So when t is equal to 0, h will also be equal to 0. Let's put it in the table. So when t is 0, h is equal to 0. The next t value in the table is 1. When t is equal to 1, h will be equal to 26 times 1 minus 5 times 1 squared. This will give us 26 minus 5, and 26 minus 5 is 21. So when t is 1, h is equal to 21. The next t value is 2. When t is equal to 2, h will be equal to 26 times 2 minus 5 times 2 squared. This will give us 52 minus 20. 52 minus 20 is 32. So when t is equal to 2, h is equal to 32. The next t value is 3. When t is equal to 3, h will be equal to 26 times 3 minus 5 times 3 squared. And this will give us 78 minus 45. 78 minus 45 is 33. So when t is equal to 3, h is equal to 33. The next t value is 4. When t is equal to 4, h will be equal to 26 times 4 minus 5 times 4 squared. This will give us 104 minus 80. 104 minus 80 is 24. So when t is equal to 4, h is equal to 24. The next t value in the table is 5. When t is equal to 5, h is equal to 26 minus 5 minus 5 times 5 squared. This will give us 130 minus 125. And 130 minus 125 is 5. So when t is equal to 5, h is also equal to 5. The last t value in the table is 6. When t is equal to 6, h will be equal to 26 times 6 minus 5 times 6 squared. And this will give us 156 minus 180. 156 minus 180 is minus 24. So when t is equal to 6, h is equal to minus 24. So we have now completed this table for the relation h is equal to 26t minus 5t squared. In the next video, we are going to use the values of t and h in this table to draw the graph of the relation h is equal to 26t minus 5t squared. Then we will use the graph to answer the last part of the question. So see you in the next video, and let's continue with the solution. Bye bye.